In today's lesson, we're going to look at how to find the surface area of nets. Now, I have skipped the introduction to nets because that'll be easier to show when I'm back in the classroom with you guys and I have some objects that you can actually use right in front of you to see how different types of prisms, three-dimensional objects, fold and unfold, so you can become familiar with the layout of nets. But essentially, a net is just a two-dimensional shape, composite shape, that when you fold it up, it will create a three-dimensional object. So imagine you have a box in front of you. It's a three-dimensional shape, and you were to unfold it so it all laid down, all of the faces of the box were laid flat on the desk in front of you. That would be a net. For those of you who like to make origami, if you were to unfold your origami shape and lay it down flat in front of you, you would see all of the individual faces of your origami shape. That would also be a net. Okay, so surface area is just the total area of all of the faces of a three-dimensional object. So let's just fill this in here. Surface area is the total area covering the faces of a three-dimensional object, and it's measured in square units. An example of a net would be the wrapping paper you use on a present that you're giving someone. Right? If you unfold that, you'll see where each part of the wrapping paper covered every face on the present. And we could find the area of that wrapping paper. So wrapping paper would be one example of a net that we could find the surface area of. All right, let's look at how we can decompose a net to find the surface area of a net. All right, so we're going to decompose this net into shapes and complete the table to determine the total surface area of the rectangular prism. We'll then label each face of the net with the area to visualize it. Okay, let's have a look at this. Okay, so we've got this net here and it's all rectangles, it looks like. Let's just identify some of the measurements we have. So this 15 right here is for this part here. I can see that this side here is 3 meters, but we can figure out the length of this because it's the same as this one here. So this would have a measurement of 8 meters, and this one here is also 3 meters. If this one's 8 meters, that means this one is 8 meters too. So we can find the area of the 3 rectangles over here on the left. We can also find all of these. Each one of these ones here I'm just highlighting in red, they're also 15. So I'll just put a 15 here, for example. And then this one here is 3. This one here is 8, and that one's 3. So got to be careful when we're doing this. And this will be a lot easier after we see what nets look like when I come back in person, but we can still do this. Okay. Let's go ahead and find the areas of each individual rectangle now. So shape 1, shape 2, and shape 3. Well, we have 3 different size rectangles, right? We have these smaller rectangles here. We have this larger rectangle here and here. And then we have these medium-sized rectangles here. Now, all three of them are rectangles. So let's just try it like this, just for reference. I'm going to say this is the large, medium, and small. So the formula for each of them, because they're rectangles, is area equals base times height. And then we can go in and plug in our values. So let's plug in the values now. So for the large one, we have 15 by 8. So its area equals 15 times 8, which would be a total of 120 meters squared. So this one is 120 meters squared. This would also be 120 meters squared. It's the same size. Shape 2 would be the medium-sized rectangles. That's these ones here. Well, these are 15 here and 3 here. So if I multiply that, that's 45 meters squared. And this one's also 45 meters squared. So area equals 15 times 3. When I plug in my values, that's 45 meters squared. And then finally, we have the smaller rectangles, and they have dimensions of 8 and 3, which means they are 24 meters squared. Okay, so now we can find the total area. Now, a couple ways we can do that. We can add up each of the individual areas. So we would do 24 plus 120 plus 24 plus 45 plus 120 plus 45. We add all of these up. And when we do that, we get a total of 378 meters squared. Another way we could do this is, I know that there's two in this problem. I know there's two of each shape. So there are 2 larges, 2 mediums, and 2 smalls. So I can multiply these by 2. So that'd be 240. This would be 90, and this would be 24. And then we could add these up. And we still get the 378 meters squared. So that's how we would find the surface area of this rectangular prism. Let's have a look at one more, and then I'll let you guys get started on your work. We're really just working with composite shapes, which we've done before. These are a little more complicated, I think, though. So we have a big rectangle here. We have what looks like a medium rectangle here, and then a smaller rectangle here. So we have 3 different rectangles. So I'm going to say large, medium, and small. And then finally, we have a triangle. We have 2 of them, right here and right here. So let's fill in our boxes, our table here with the information we have. So for the large one, we know it's going to be area equals base times height because it's a rectangle. For the medium rectangle, again, area equals base times height. And for the small rectangle, area equals base times height. For the triangle, area equals 1/2 base times height. So let's go ahead and plug in the values. For the large rectangle, we're looking at 5 times 7. Those are the dimensions. For a total area of 35 centimeters squared. For the medium rectangle, we have a height of 4 and a base of 7 centimeters. So this would be area equals 7 times 4. So that's 28 centimeters squared. Just write that in here. For the medium rectangle, the small rectangle, we have a height of 3 and a base of 7. So here's 7. For an area of 21 centimeters squared. And for the triangle, we've got a base of 3 and a height of 4. For a total area of 6 centimeters squared. Now it is a little confusing here. This 3 right here is also the height and base of that, okay? So just to be clear, that goes there. So we've got 6 centimeters there, 6 here, and we said this one was 21. So now we'll total that up, and our final answer, after we add each object's area up, is 96 centimeters squared.